has an area of 3. And finally, the space over here
so we know that it ends at 6 because it says from 0 to 6.
correct.
Well, that's
It
awesome.
says right here from 5 to 6. No. The thing you said that's important is you found a reason for your edges, not just kind of making up math.
Right, okay.
So that area is 2. Questions about anything so far? Anybody? Keep reading. At time equals 0, the particle is at x equals -2. I'm going to write that down. So x, the position, when time is 0, is a value of -2. For this time period, find both the time and the position. Probably circle that. Time and position of the particle when the particle is farthest left. I happen to have memorized that farthest left is exactly the same thing as finding the very minimum value of x of t. Questions so far? Justify my answer. So I immediately recognize it as a min-max problem. So my flashcard memory says the min-max theorem guarantees that the position will be least at the beginning of the position, the end of the position graph, or at a critical point of the position graph. The critical points of position occur when the derivative of position is equal to 0 or undefined. So I write in my paper, v of t is equal to, let's see here, v of t is equal to 0 at, and they told me in the problem, t equals 0, 3, and 5. So now I know the particle will be farthest left for sure, either at time 0, 3, 5, or 6, the end time. Questions? Meg, please.
I'm just a little bit confused how a particle being farthest left would be a minimum on the position.
On the position. So if I draw the position, well, let me keep talking, and then we'll kind of fill it at the end.
Wouldn't you have to add 6 to that?
I don't, hey, 2 for Spencer, 2 for Maggie. Look, I don't want to put 6 here because I'm saying that the velocity is equal to 0 at these times. Here's the velocity graph, and at time equals 6, the velocity is definitely not 0. What you're thinking is, yes, the particle could be farthest left at time 6, so I'm mentally remembering that, but I don't want to put that here.
So if you memorize that x has a limit at any zeros on v of t and any critical points on x, is that right?
Let me say it back to you. X of t has a min at either the endpoints of x of t or the critical points of x of t.
Oh.
And the critical points of x of t are definitely where the derivative of x of t is equal to 0. So I now know 4 places I need to worry about. Time 0, time 3, time 5, and time 6. Other questions? I'm just going to do integrals. So let's see. X of 0 is -2. I've already done that. So if I want to find x of 3, I can use the fundamental theorem and say, if I take x of 0, add to that the amount by which x will change. Whenever I do an integral on the AP test, I write down the integral. Between time 0 and time 3, that's right up here. Time 0 to time 3, this integral is going to be -8. So -2 plus -8 is -10. I found the position at time 3. Any follow-up questions there about anything? Please. Gotcha. So let me say it back to you. So if you wrote all of this and then said equals -10.
Yeah.
Perfect, no worries. Please,
Can you remind me why?
just write the integral for sure.
When we're looking, we know we're looking for a minimum, and like on the Amicus chart, it's only when it goes from increasing to increasing, why we look at all the zeros.
Gotcha. You have to keep separate the concept of relative min versus absolute min. In this problem, they never use the word relative, so it's absolute min. And the absolute min can occur at the endpoints. The absolute min can always occur at the endpoints because the graph could be just going down. It didn't change, it didn't have a relative min there, it just just went down. Now I am checking at some places where the graph was going up, which is, I know it's not going to be there, but I have to justify it somehow. So I either have to justify via a sentence or an integral. I just prefer the integral because I can see it's going to be so easy.
But like your sentence could have been because it's going from increasing there, or
So
positive to negative.
I can do this, so I can write this just to illustrate what you're talking about. I can say, let's see, time, right? T equal 5, at T equal 5, V of T changes positive to negative. So X of T has, see, I just don't like doing it this way. I feel uncomfortable. I can't tell if I'm going to justify it properly or not. I'm going to say X of T has a relative max.
But you don't know if that.
But then I'd have to maybe say something why I know that's not where it's at, because it's like mostly left. The numbers to me are easier justifications, so I prefer, like, it's not wrong, you can write it out.
Okay, so it won't be those numbers. Like
No, it won't.
Okay, you just have to justify.
I just have to justify it.
Okay.
Is that kind of answering your question?
Yeah, I just thought, I was like, well, there's no way you can do that because again, it's just, that it makes sense to just have to actually state that.
Yeah, no, you're understanding it perfect, Em. It can't be, and I know it's not going to be, but I have to have some justification.
Okay.
Or I will lose a point on the, like right here, shows how it's scored.
There is no, I mean.
Oh, this one didn't actually talk about it, so they kind of left out, but
But
they often
most
do.
problems they do.
Yeah, most said can. Usually they give a point for justification. Please,
If I say the integral from 0 to 3 of velocity is equal to -8, and then on the next one you put -8 equal to x of 3 minus x of 0, is that okay?
say it again. I gotta see it. Finish it.
So it's
Just let me know. Yeah, that's fine.
and then minus x of 5 plus x of 0.
Yeah, that's fine. Totally fine. Different way, doesn't, either way is fine. Hey, so we'll go 0 to 5, v of t dt, that's going to equal -2, plus we get the -8, the other portion is 3. Or arithmetic brain, so that's -7. Yes.
So, you could find like the integral from 0 to 2 or the integral from 0 to 4, could you?
That is correct. Because of the picture they've given you, there is no way to find the value of the area other than the area they specifically gave, because it's not a simple geometric shape.
Right.
Yep.
Now, they then give you the equation of these lines, which.
Correct. If they gave you some equations, then you could do it.
Why don't we use -8 and positive?
So whenever you integrate going left to right, areas above the axis count positive, areas below the axis count negative. Is that your question? No. Say it again.
Like, for, plug in -2 for.
-2 is the value. So I'm setting up the fundamental theorem here. So I'm rushing due to the time. X of 3, like the position of the particle at time 3, will be wherever the particle was at time 0, added to by what amount will the particle's position change during the next 3 seconds. So the particle starts at -2. During this 3-second time period, the velocity is always negative.
Yeah.
This also helps explain why it counts negative, because the particle is going left. So the position changes by -8.
Okay, so for x of 5, what about that?
So for x of 5, I say, okay, started at position -2. From time 0 to time 5, during the first 3 seconds, it went 8 to the left. Now it came 3 to the right. So did that answer your question?
Yeah.
Okay. Somebody help me, what is it? Sir? Take a night thing. Once you've written out that, you just write down, therefore the particle is most left at time equal 3, where the position is -10. And you're done. Follow-up question.
Do we have to write like all the arithmetic stuff, or can we just write?
So the things that would be required, Pam, is I would for sure write this.
Okay.
It goes back to what Cannon said. I've just seen so many FRQs where they give a point for this. So I would write that for sure. This one didn't have to be written. It was in the notes. That was for me. I always write the integrals.
Okay.
So I would write the integrals for sure. You don't have to write this.
Okay.
You can do it in your head. Does that make sense?
Just a question.
Please.
Would you still have to write it even though it says it in the explanation?
Says which part?
The V of t equals 0 at,
Oh, I gotcha.
because it says velocity 0 at time equals 0, time equals 3.
I still write it just because I know every min-max problem I've ever solved, that seems to be a key to getting some points. That's why I wrote it. As I was writing it, I literally had the same thought you had. I was like, do I really have to write this? But not sure. Yeah, because well, and I don't get to see the scoring guide while I'm taking the test, so yeah. That was good. We should say that again. It's on video now forevermore, so. Mr. Smith's wise words of wisdom. By the way, you don't get to see the scoring guide while you do that. I hope you all are aware of that, so. Bummer.
Scoring guide up there, it says considering the integral of 0 to 6. Even if we know that that's not going to be the most left or the most whatever, should we still write it as our left? It's at the end of our
It's part of the justification. It's because, look, the reason, this is back to M's question as well. Hey, the reason it's super important for you to check what's happening at time equals 6 is the particle is moving left from time 5 to time 6. So I need some sort of mathematical proof that it didn't end up further than -10. That's why they require that you have that integral. That's absolutely required. So, please.
Just the way that I did it, like after I found what x of 3 equals, I used that to do the next integral, so I only had to go from 3 to 5.
Totally fine.
So then like I didn't have 0 to 6, I went to 5.
Totally fine as well. Yeah, they will give you this exact same credit because you're just building as you go. That's what Seth was actually doing. So totally fine. 2 pebbles for that. Okay, every other questions here? Awesome. The way points were awarded is the conclusion I didn't write was worth 1 point. This was part of the justification. I kind of explained that. And then this was the part that Forrest asked about. They're asking that I consider it as a candidate. Here's kind of 2 places where I'm considering it. I wrote here, and then I did the integral. So I'm definitely considering it.
So for justification, I took out particles for the stride at time 3 and the particles at -10 for the, like, for the conclusion.
Oh, the conclusion.
Yeah,
sure.
so I
For
got
this lab.
justification, yeah.
Yeah, for conclusion.
Okay.
Sorry for hurrying. We're just short on time. Okay, look. I don't have time to write this one out. I'm just going to talk you through it. This one requires a bit of writing to get the points. Basically, we did everything here. It's a matter of looking at the graph of velocity and stating in words. From time 0 to time 3, v of t is negative. So the particle is moving left. So the particle starts at a position of -2, moves left until it's at a position of -10. Therefore, there was one time so far where the position was -8. It had to. Does that make sense? The particle was at -2. For the next 3 seconds, it's only moving left. It's got to go from -2 to -10. It must have had a position of -8. Now, you do have to say that you know that by the intermediate value theorem, or they won't give you all the points. You have to use, because the -8 is an intermediate value between -2 and -10.
You need to know.
So you have to say the words by the intermediate value theorem. You can abbreviate IVT.
How many of them?
One at a time. Kind of.
Are you allowed to build off like previous problems, so you don't have to
Yes.
rewrite everything?
Oh, yes. So here, hey, that's why the FRQ is laid out like this. So whatever happened here, you can reference. You can just say, oh, you know, at time 0, the particle's at -2. 3 seconds later, you have to give all the reasons.
Yeah.
This is one of those problems that as I start working it, I might skip it. Because I can just tell already I've got to write a lot of stuff to convince the grader I knew what I was talking about. It's a lot of writing. So, but that's the idea. Again, I'm rushing a bit. But the idea is that you've got to write several sentences. So then you say, okay, from time equal 3 to time equal 5, the velocity is positive. The particle is moving right. The particle moved from -10 to, what was it, -7. Hey, once again, by the IVT, the position had to have been -8 during that time period. And then one more statement is what's required.
You have to know the name of the immediate value theorem.
You do. They used to be less strict on that. They've become more strict on that as of last year. So they expect you to say, you're talking about how you start at this value and you hit every intermediate value in between.
So are there a lot of things like this that you need to know the exact terminology?
In fact, I feel quite confident saying if you're good at all the other stuff, you can still get a 5. There's not enough questions like this to keep you from getting a 5, since 66% is 5. See, this one goes fast. Watch. I would write the following. Speed is equal to, memorized fact, the absolute value of the velocity. The absolute value of the velocity is increasing. Let's see, so you flip this up. I was asking for D. I'm just going too fast. So on this time interval, 2 to 3, so it would be decreasing, because this would be the absolute value. The absolute value is decreasing on the interval 2 to 3. That's it.
Is this okay if I did it this way, or is it just a quick way?
Go ahead.
You know,
This is Danica's chart.
the acceleration and the velocity are opposite signs, positive and negative?
Yes, you can do it that way.
That's also-
Yeah, that's valid. Just as long as you explain that. By definition, that's what speed means. It really is nothing more than that. Somebody just said, hey, we'd like to have a word for, like, velocity has a value and in physics, has a magnitude and a direction, okay? Has a number and a sign. It's a vector. Yeah. Like in the movie.
Why?